Hello students, so today we are going to study about lot of gravitation. So let's just start the video. So in my last video I have talked to you about universal law of gravitation, and it talks a lot about how sun and earth why earth revolve around the sun or moon revolve around the earth, or why our ball doesn't go straight up, it always comes down. So we have talked about it. Okay, it straightly means that force is equal to capital G m1 m2 upon r square. Okay, so you just say that if you have mass and you are separated by a distance, you will surely attract each other. Okay, so it was given by Sir Isaac Newton, and we have talked a lot about this formula. Let's just see what's the importance of it. So yes, we could understand that how moon revolve around the earth. Yes, we understand that why earth revolve around the sun. Now the new concept, new phenomenon is that earth is very near, or moon is very near to the earth. Okay, but sometimes it comes really near. Okay, now what happens, it also attracts the earth. It started attracting the earth, but it has a lot of mass, so you can't see the shift, but you can see the movement of water. Water is on surface of the earth, and when moon comes near to the earth, the water started going towards the moon and creating a high tide. And where moon is not there, the water is still, it's like a flat. So this is due to the gravitation. The moon is attracting the earth, but earth has a lot of mass, so it can't shift. So the surface water shift. Don't assume that you will stand there and you get attracted. Not that, only water, because it is a fluid and it has a lot of mobility. Now next and very important, that gives us the whole new topic, is the force that binds us to the earth. Yes, if gravitation would not have been there, you are floating like a bird in the sky, or we don't have atmosphere, we don't have gases. Gases are attracted to the earth, that is why it is creating a surface. We are walking, we can walk, we can talk, we can sit, we can jump because of gravitation. But when you go to the space, the astronaut that went up to the space, they just float around. They have a very difficult life there. They can't sit, they can't walk. But we in the earth enjoy the power of gravitation, and we just walk around, we can jump around. Now next, okay, free fall. Yes, now let's just see, you are saying, okay, I have thrown a ball and it went down. If both masses are attracting, and they are attracting to each other, why my ball is only attracted to this earth, not the earth is attracted to the ball? So I have told you that moon can't attract the earth because earth's mass is very huge, like a lot. So it can only see, we can only feel the gravitational pull of moon by seeing the water. So how can you say that the small teeny tiny us, or a ball, or anything, objects in the earth, when you just throw it and it comes, earth will also shift? No, it's not, because its mass is very less as compared to earth. So what happened to this ball? Why it is getting back? Because of force. That force is known as gravitation force, but we also gave it another name. We gave it gravity. We gave it gravity. Okay, so this ball went up due to your velocity, and it is coming back. It is not magic that it is coming back, it is because your force. No, it is coming back. because of gravity. So gravity is making this ball to accelerate, and due to this acceleration due to gravitation is known as small g, yeah, gravity. Okay, so very familiar, or I can say very familiar formula that you are seeing in front of your eyes is F is equal to ma. Yes, I know this is the second law that we have read there. The Newton has given the second law. Yes, this was given by Newton. And now what I am talking about, this formula is this ball is making an acceleration, okay, and this is acceleration due to gravity. So just change this acceleration and give it a symbol small g, because I want to just differentiate between this acceleration and this acceleration. This acceleration can due to anything, change in velocity, and that change in velocity is by anyone, by you, by anybody, but small g is due to gravity. So let's just start doing the derivation that we are having. So Newton said that, okay, ma is equal to g m small m upon r square. So this is the object, this is the mass of the earth, this is the object's mass, and this is the distance between earth and the object. So small n cancel, and I have to write it g. So small g is equal to capital G, capital M, and r square. So I got the acceleration due to gravity as capital G, capital M, r square. Okay, so if I get the mass of the earth, if I could, I know the capital G value, and if I get the radius of the earth, so I can get the small g. Yes, definitely. Put the value. See, earth has lot of mass, 6 into 10 to the power 34. Like, it is not 60, it's 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. My space has been over. Okay, so 34, and radius is also large. Now we get the answer of small g as 9.8 meter per second square. Meter per second, because it's acceleration, but we are writing it small g to get differentiated that it is by gravity. Now next, motion of objects under the influence of gravitational force of the earth. Yes, we have studied it, like we need to just replace a by g. Now you need to understand, you have learnt about the equations of motion 1, 2 and 3 that you have learnt. Just displace this a to g, small g, and your motion of the object, equations of motion due to gravitational force of the earth has been done. Like I have just changed the small a to just small g, just to differentiate between the gravitational acceleration and the normal acceleration that can done by anybody. Okay, now numericals are the hardest part of the physics, everybody think, but it's quite easy. Let's just see how. So there is a car fell off the ledge and dropped to the ground. Okay, so this is a car. I think this is a movie scene. This is a car, and I think it is moving in all. I have made this. Okay, this is the car and it moving with lot of speed. Okay, now this is a cliff and they doesn't see the cliff, and this car went straight down, and this car, okay, this car goes down and this boom. Now what happened? The time taken by the car to reach the ground was t is equal to 0.5 seconds. Okay, you got the time. you got the time, you got the g, that is acceleration. Now it is so easy. When you are solving the problems of acceleration, you have to find the acceleration, but in this chapter you have got the acceleration in your hand. G is equal to 10 meter per second square. Now first question is speed. Now you need to see the speed. Okay, this is the u and this is the v, final and initial. Initial, if it is falling in on the ground, it must have the velocity 0, and at ground I don't know. So let's just see the formula, plus a t. Now v is equal to 0 plus 10 into 0.5. v is equal to 5 meter per second. That's your answer. Next, the average speed. Okay, now for average speed, what you do? Total distance upon total time. Okay, don't know the distance, so what you will do? S. So total distance upon total time. Okay, this is speed, this is speed. Okay, call it v. So we need to find S. V square is equal to u square plus 2as. Now we have got 25 is equal to 0 plus 2 into 10 s. Now 25 is equal to 20s. 5 by 4 is s. Now 1 point, okay, I need to do it. 1.02 to 1.2. 1.2 upon 0.5, that is 2.5 meter per second. Don't you forget, you will lose marks if you don't write SI unit. Now height, that we have found, like 1.2. That's your answer. S is equal to 1.2. Okay, you got the answer. Let's just go with the next slide. Mass. Okay, mass is measured by kg. Mass is measured by the how much inertia a object have. Oh, I have just written it. You can see, measured of its inertia. If increase in inertia, increase in its mass. So mass. So you always say that my weight is 50 kg. Okay, this kg, oh my god, you are talking about your mass. No, you're not talking about the mass. This is the myth. Now what happened? Oh, you are talking about weight. If you'll say I weigh 50 kg, you're not weighing 50 kg. You are weighing 5 into 10 5 into 10 kg meter per second square, 50 kg. Okay, so let me talk about this in detail. F is equal to mg. Your mass is only 5, and due to gravitation force pulling you down, you need to multiply it by small g and you'll get your weight. Okay, so don't ever confuse with mass and weight. The actual weight that you have is of F is equal, you are just calculating the force that earth is just the earth is pulling you. Okay, and the mass, actual mass, is the actual mass that you have. Now what happened if I talk about this earth? Small g is capital G m upon r square. So if I talk about moon has small radius, it has small mass than earth, so we can say that its g will be different from g of the earth. Yes, it will be. So your mass that you're talking about will be different on your mass will be same, but the force or your weight will be different when you go to the moon. Let's just see. This is the chart that is made. Earth and moon, they have got a particular mass and radius. Just put it G E upon G M, or I should just make G M upon G E is equal to capital G M of moon and radius square of moon. Now capital G mass of earth and radius of earth square. G will cancel because it is universal, so you will write G M upon R M square into R E square upon M E. So the value you will put the mass of the earth and radius, all that is a huge calculation, and your value will come 1/6, means that Gm upon Ge is equal to 1/6. Interchange it. 6 Gm is equal to Ge, and your mass is same when you are in earth or moon. Okay, so your mass on earth is 6 times the mass in the moon. That means you have a lesser mass in the moon than earth. So you can say that if your weight is high, you can say that I am in the wrong planet, I should be in the moon, I would be weighing very less. Just joking. Let's just start the next thing. Thrust. So gravitation is over. This is the new concept, this is the new thing that you need to learn. Thrust. Now this is the object. You are forcing, you are making a force by your hands, and I can't make a hand, and you're dragging it to here. Okay, your force has been just done. Now thrust is exactly the force, but perpendicular, means like this is the object, this is the force. If this force is there, you are having thrust. Okay, you're not having force, you are having thrust. Okay, thrust, you can find thrust same as the force. Now pressure, this is the important thing. Okay, so whenever you have you just press your finger, your hand with your finger, do you feel pain? No, but doctor, when it gives you injection in your palm, you feel lot, like this is your arm. Okay, this is your arm, you feel lot of pain. Why does this happen? So I will tell you. This is due to pressure. Okay, lot of time you all say that I have lot of pressure in my head. This is your brain, and this is the pressure that you have for your studies. So this is the pressure, means something is dragging you or pushing or pressing you like very hard. So in physics you can measure this pressure. Pressure is equal to force upon area. and let me remind you, this force is perpendicular force, so we can say that pressure is equal to thrust upon area. We can say that. Okay, that is why you feel lot of pain while doctor is just piercing your skin with the injection, but when your friend just touch with the finger, you don't feel anything. Okay, so what happens in there is that area of injection needle is very small, it is pointed. That means area is very less. If area is less, pressure is more. If area is more, pressure is less. Simple. So even doctor and your friend is pressing you with the same force, you feel lot of pain with the injection than with your hand. Next, pressure in a fluid. Yes, the application in the physics of pressure is a lot in the fluid part. Now what is fluid? Fluid is anything that flow. I can say liquid. Okay, I can say gas. Yes, these two can flow, that is why they are fluid. Now there is an object right inside, and it is in middle. Okay, and you don't know why it is not going down or why it is just not going up. It is due to the pressure. Okay, the water molecule is creating perpendicular pressure in every direction, and every direction pressure gets cancelled. Now this pressure cancels this pressure, so there is no pressure. And balance force create motions, so there is always balance force, so it get balanced by every forces and it becomes balanced. Okay, so this is the pressure in the fluid. Next, buoyancy. Okay, when this is the river, okay, you'll see cork or a wooden block doesn't sink while your I can say ball sinks. Okay, and when you jump, you don't sink, like you feel caustic or you feel no oxygen, but frankly speaking, you're not sinking. Why does this happen? Okay, so there is some force that this wooden block is this is the force of gravitation. Earth is pulling it, but there is also a force that is dragging him upwards. Okay, that is why it is not getting down. If surely only the earth's force is there, so it could have sinked, but it is not sinking, it is rather being balanced on the surfaces. Why? Because there is the upward force, because of some upward force, and that upward force we call is the buoyancy force, that you call as buoyancy force. The buoyancy is the reason why everybody can swim in the water, or fishes also swims, or wooden block doesn't sink and ball doesn't sink. Now sink and float, yes, so I told you that wooden block doesn't sink, but the ball sinks. Why this difference is there? Is this water knows about that this is the wood, I need to float it, this is the ball, I need to just sink it? No, that is not the clear-cut division. It is due to the density. Now density is a big term. Density. So density, if you ask me the formula, density is represented as rho is equal to, this is the Greek symbol rho, it is mass upon volume. Okay, so density of wood is far less than the density of ball, that is why it sinks. Okay, but we also see a oil. Okay, we have seen water and we have seen oil. Okay, why oil can't sink and why not water? is float on the oil. So every liquid has its own density, its inherent density. So water has its own. So we have calculated it as 1 gram per meter cube. Okay, so if your volume is less, you will have greater density. If your mass is low, you will have lesser density. Okay, so this is how, if your density, this is density of water. Okay, your density of the density of water, and this is the density of wood, this is the density of ball. If ball's density is higher than this water density, it will sink. If let's just note it down correctly. This is the density of water. If density and ball has greater density, that is why it sinks in the water. Okay, but wood has lesser density than water, that is why it floats. Okay, so you'll say that why not this ship, this huge ship cruise does not sink in the water. See, what this is having sols, this is having a particular shape which makes their volume very less. There are a lot of reasons, there are a lot of physics involved in this. First of all, they make a volume very less at the surfaces, so water has water experience very less volume, so that is why it never sink in the water. But when you press a hole and water comes inside it, it will definitely sink. Okay, next, Archimedes principle. It is a very important principle. It's principle you need to learn by heart. Okay, it says when a body is immersed fully or partially in a fluid, it experiences an upward force. That upward force is the buoyancy force, that is equal to the weight of the fluid displaced by it. So it is saying that if you jump inside this water and you displaces some water, okay, you displaces some water, this displaced water is equal to the force that makes you float in the water. So this is nothing, this okay, let's just take a simpler example. Take a water, take some cork. When you put this cork inside, the water displaces, okay, and make a hole in it, and this displaces and the water level high, and this fluid will went down. This fluid mass and this body's mass, these two have the same masses, so this says about the upward force that is equal. Now, Archimedes principle has many principles. It used in designing ships, submarines, lactometers, which is used to determine purity of sample of milk, hydrometer used in determining density of liquid as based on this principle. So when I see this purity, Archimedes sir has given this way back earlier. Now he is a member in the court, and king has offered, I think this was the story, king offered him that, okay, this go and calculate the purity of this crown, and he went with this crown and just very confused how he can compare or how he can measure a crown purity. So what happened, when he was bathing in the bathing tub, he see that when he went down, this water moves up. So he take the pure gold and he see the displaced water, and when he put the crown in in the water, it displaces the same water. So he got the idea, okay, this is how we can calculate the purity, and that is why we can determine the sample of the milk. Next, relative density. So density, when we can relate with anything, is the relative density. Basically we relate density because we wanted to know how the substance sink or float, or how it behaves when you it is basically for the water. So what does relative density do is that density of an object, or the density that you want, upon the density of the water, and you'll get your relative density. So relative density doesn't have any SI unit, or or it doesn't have any unit, because density has SI unit of kg meter inverse cube, kg meter inverse cube. Both density cancels, there was no unit. So this is how this chapter ends. Thank you. If you like the video, please like, share and subscribe to this channel.